Okay, the point of this example is just to run through all the things they did in this section. I'm just trying to summarize what they did, summarize the way they did it, and see what we can come up with in the long run. Now, according to the problem, we're running jet fuel through a pipe, and every foot of the pipe removes 20% of the pollutants, and we're supposed to analyze the function where x is the number of feet that we run the jet fuel through, and we would like to know the pollutants value based on top of that. The very first thing I'm going to do is I'm just going to make a table, a nice simple table. Where we see what's going on. Like that. I know that if I run it through 0 feet of jet fuel, it's still got 100% of all the pollutants. Looks like that. Okay, if I run it through 1 foot of jet fuel, I'm supposed to lose 20% of the pollutants. And I just want to write this out. So I'm going to get the original amount of pollutants, yay, and then I'm going to lose 20% of those pollutants. So it's 20% of what I had, like that. Now, I'm going to do 2 things with this. I'm going to work it out, and then I'm going to leave it. If I work it out, I'm going to see that I get 100, let's see here, minus 20, and that's going to be equal to 80. So I'm left with 80%. Now that's what happens if I work out the numbers. If I don't work out the numbers, I'll actually see a pattern more quickly, and that's actually what I'm going to do. What I'm going to do is, instead of multiplying that out, I'm going to look at this little piece right here, and I'm going to factor out 100 because there's 100 in each of them. So this is going to be 100 times 1 minus 0.20. Now that brings up a lot of things that showed up in those 2 videos and in the reading. First off, you can see that from here to here, I took 100 and I multiplied by 1 minus 0.20. Now we were told that the growth rate was negative 20%, and we can see that we multiplied 100 by 1 minus 0.20. This is called the growth factor, where the growth rate here is negative 20%. I'm going to run through another whole line doing it exactly the same way to see what happens. So when I run it through 2 feet, I can take my 80, and I'm supposed to lose 20% of my 80, like that. Now I'm just going to work this out. I'm going to get 80 minus 16, and I get 64, which is certainly correct, but I'm going to have a really rough time finding a formula this way, so I'm not going to do it that way. I'm going to do this much longer and horribler, right? Instead of the 80, I'm going to put what was equal to the 80, and let me put this in red. 80 was actually this. And you might think, gee, this is horrible, but we'll see a pattern happening this way. So instead of the 80, I'm going to put what the 80 is equal to. So this is equal to 100 times 1 minus 0.20. That's the 80. Now what am I supposed to do? I'm supposed to subtract 20% of the 80, and again, the 80 is what's in the red box. So this is going to go like this. I get 100 times 1 minus 0.20. How much of that can we see? We can see the whole thing. I can put a little thing like this. Now again, that looks far worse, but I want to do the same thing I did last time. I see 2 terms. I see this one right here, and I see this one right here. And I just want to take out what they have in common, and oh boy, they have a lot in common. In fact, they both have 100. They both have a 1 minus 0.20, so we're factoring them out, which means dividing by. So I'm going to take out 100 times 1 minus 0.20, and I'm just going to try to see what's left. Okay, when I take this first term, 100 times 1 minus 0.20, and divide by 100 times 1 minus 0.20, I get 1. Yay. this minus sign is still here. Yay. Now, when I look at the second green term and take out 100 times 1 minus 0.20, what's left is 1 minus 0.20. I get that. Now, that might not look as nice as the 64, but we can see a pattern just popping out. And let's write out what the pattern looks like. We're going to get equals 100 times 1 minus 0.20 times 1 minus 0.20. I'm going to get 1 minus 0.20 quantity squared. There's already enough here to see a pattern as long as I go back and look at this line here and say that's not just 1 minus 0.20, that's 1 minus 0.20, ta-da, to the first. So what I actually see here is a pattern. I see that when x is 1, I get 100 times 1 minus 0.2 to the 1th up there. When x is 2, I'm going to get 100 times 1 minus 0.20 to the 2nd. Let's go back up here. Fill in what would happen if we had 3. If we had 3, I should have 100 times 1 minus 0.20 cubed. If this was 4, I would get 100 times 1 minus 0.20 to the 4th. And so we can see actually how this function works. You tell me what x is, and I'll put x into the exponent. That's all it is. That's why they call them exponential functions. That allows us actually right at this point, just by following pattern recognition, to write out a formula. We should see 100 times 1 minus 0.20, and the x goes up like that. Now, just a reminder of what they said in the section and in the videos. The growth rate here is I would like to say 0.20, but it's actually negative because it's decaying. I can write that as negative 20%, like that. So that's actually the percentage change each time. Now there's something called the growth factor. Now the growth factor, if you look back at our table, was what we were multiplying each y value by to get the next one, and we can just see that was 1.2 in this case. Now the letter they normally use for growth rate is R. The letter they normally use for growth factor is B, and the equation that they usually write down for an exponential function should be an initial value, which is 100, times b to the x. So we can see in this case a is 100. We can see that b is 1 minus 0.20. We can see that the growth rate is negative 20%. And what I'd like to do is just take a minute here and do this real slowly, is go over to Desmos and just start putting in stuff and make a little table and just see what we can do here. So I want to go over here. I'm going to write down, I think, f of x, after we work so hard to find a formula, is equal to 100 times 1 minus 0.2 to the x, like that. I think I'm going to try to make a little table of values. Doesn't have to be a big table, but what the heck. Over at y1, I'm going to make this f of x1, like that. I know that we were going up by 1, so I go 1, 0, 1, 2, 3, 4, and we get some numbers, so the same numbers we got before, which is nice. With Desmos, you can make it by going over to this little minus sign over here, make it plot the points, and there's the points. There's the graph. You can see that it's decaying very quickly. You can see, by the way, that the percentage, even though this looks really small, it's Not getting that small yet. It's kind of weird. At any rate, that's pretty much everything. We have an exponential function. This exponential function's graph is concave up. It looks like it has an asymptote way to the right, but we'll discuss much more of that later. I think we've run through everything they've done in this section with this example.